Hey, good afternoon. So in the last session, we started with the dynamic routing. And in the dynamic routing, we have seen about EIGRP and RIP. RIP is an obsolete protocol, distance vector protocol not being used. Okay, then we have EIGRP, hybrid protocol has the features of both distance vector as well as link state. Okay, now let's today talk about the OSPF protocol. OSPF is a type of link state protocol. Now link state means what? We'll focus on the bandwidth. Okay, so let's see. OSPF stands for what? Open shortest path first. Now, why OSPF is known as open shortest path first? First reason that it is a open standard protocol. Second reason, it uses die-fast shortest path first algorithm. Okay, so there are two reasons. First, it is open standard, and second one it is using shortest path first algorithm. Okay, these are the two reasons. So your open for OSPF came from here, and SPF came from here. This is why it is open shortest path first. Then it is a link state protocol. Okay, it's a link state protocol and uses protocol number 89. What is the protocol number being used by your EIGRP? What is the protocol number used by EIGRP? Yesterday only we discussed. Two protocols. That is two AD values, not protocols. 90. 90 is the AD value. 90 is the AD value. Sorry. Protocol number 88. Right? Protocol number 88. Then what is the AD value for EIGRP? 94 internal routes, 174 external routes. Correct? Then multicast address. Multicast address. What is the multicast address being used? Yes, 255. 09. Is it? Yeah, for RIP. I'm asking age after. Yeah, exactly. Okay. For RIP, it is 224009 and not RIP. RIP version 2. Specific. RIP version 1 uses broadcast 4 times 255. Right? Yeah. Then after, what is the algorithm being used by your RIP? What is the algorithm used by RIP? Which algorithm your RIP uses? No idea. Bellman-Ford algorithm. And what is the metric used by RIP? I are used by EIGRP, not RIP. Don't mix up the concepts. Right? RIP uses hope count metric. Okay. What RIP uses? Hope count metric. Now see here. AD value for OSPF 110. OSPF uses two multicast addresses, which is 224005 as well as 22400. 6. 005 when your traffic is going for all the routers, and 006 when your traffic is going for DR and VDR. Now, what is DR and VDR? We'll discuss about it. Okay. Designated router it is known as, and backup designated router. Then it uses Dijkstra's algorithm. The full name is Dijkstra's shortest path first algorithm. Sometimes you call it as a SPF algorithm also, in short. Okay. Now your OSPF uses what? Area concept. So what is this area concept? OSPF is a IGP protocol, correct? So if OSPF is a IGP protocol, that means it will provide communication within a single AS only. Now in a single AS, what if there are hundreds of routers? The routing information traveling from R1 to R100 will take a lot of time, correct? So what your OSPF does for faster convergence, for sharing the information fastly, it is going to divide your autonomous system. It is going to divide your autonomous system into smaller parts. Okay, and those smaller parts are known as what? Areas. For an example, you can say that consider this is your one autonomous system. Okay, in this autonomous system, you have routers. So that is too big. That's too small. Okay. This is one autonomous system. Okay. And in this autonomous system, you have multiple areas. How? Now these can be hundreds of routers. I have drawn only few. Now, if I say that this is one autonomous system and it will take a lot of time to travel the information from your R1 to R100, right? So what your autonomous system is going to do? It is going to divide it into smaller parts. These smaller parts are what known as what? Area. And we give area numbers, from like area 1, area 2, something like that. Clear? So in OSPF, there is an area that is known as area 0. There is an area which is known as area 0 and which has a spatial significance. Area 0 has a spatial significance. Why? Because this area 0 is known as backbone area. Now, like in our human body, what is the role of a backbone? What is the role of backbone in human body? Provide strength, right? And to keep the structure, right? So same thing is there with the area 0, that if you have two areas, by default, they will not be able to communicate. Let's say, for example, this is not area 0, this is area 1, and this is area 2. So these two areas, they will never communicate with each other. If they have to communicate, they need area 0. Without area 0, they will not communicate. That means the information from here will never arrive here. The information from here will never arrive here. Is that clear? This is why area 0 is required. Area 0, it is known as the backbone area, and two areas, if they want to communicate either physically or virtually, they have to be connected to area 0. Either physically or virtually, they have to be connected to area 0. Okay. Now, understood the area concept that your AS, this is one autonomous system. This is one autonomous system. So this one autonomous system is divided into smaller parts. And these smaller parts in OSPF, we call them as a area. One area will have information about the routes and networks of that area only. They will not have information about the other area. Then you can say that, okay, how it will provide communication between the two areas? Because these two areas still belong to the same AS. And OSPF is supposed to provide communication between different AS, within an AS. But still these belong to the same AS only, right? So OSPF should provide communication. So in OSPF, we have a spatial router itself, which will be part of both the areas. And we call them as a ABR, area border router. Area border router. So again, area border router, according to Cisco, there is a different definition. According to other vendors, there is a different definition. What Cisco says? Cisco says that ABR will be a router whose at least one interface is in there in area 0. At least one interface should be in area 0. If one interface is there in the area 0, then all the areas can communicate via that. Area 0 is also known as transit area, from where all the traffic will pass. Okay. And other vendors will call them that, okay, the router that is providing communication between two areas, that is known as area. But again, between two areas, the communication will not be possible until or unless area 0 is there. This is why Cisco has modified the definition that at least one interface should be there in area 0. Remaining interface doesn't matter on which area they belong to. We don't care about that. But at least one interface should be there in area 0. This is clear? Okay. Now, when we were configuring EIGRP, we were giving what? Autonomous systems, autonomous system numbers. We were giving autonomous system numbers like router, EIGRP, and 100. So that 100 was what? Autonomous system number. Correct? In OSPF, we use their process IDs. Okay. And this process ID will range between 1 to 65,535. Okay. Then after, in EIGRP, when we were doing the configuration, I said that, okay, your autonomous system number should be same on all the routers. Your AS number should be same on all the routers. While in OSPF, the process ID can be same, can be different, doesn't matter. Why? Because this process ID is local to the router. It is not matched with any other neighbor. Is that clear? So this can be same, this can be different, does not matter. This is clear. Then in OSPF, we have DR, BDR, I'll come to it. Then OSPF is a classless protocol. It will support your VLSM and CIDR scheme. Okay, that means subnetting will be supported, and OSPF does not perform auto summary by default, so we don't have to give that no auto summary command also. Is that clear? And in OSPF, all your routers, they are identified with their router ID, not with their IP addresses or names. Routers are identified with their router ID. So what is the router ID? Now here you will see the use of loopback interface. One other use of your loopback interface. One use, we already know that we test the configuration without connecting PCs. Second use, it is used in the OSPF for router ID election, for identifying the router. Okay. So how a router, see, doesn't matter you're configuring or not, router will always select a router ID in case of OSPF. Okay. And in EIGRP also, router ID is selected. There is same method, but EIGRP router ID is not having so much of significance as much as it is there in your OSPF. Okay. So in OSPF, your routers are identified with their router ID. And how the router ID will be elected? So the first preference will be given to manually configured. First preference will be given to manually configured. That means you have manually configured a router ID. Okay. If you have not manually configured, then it will check highest IP on any loopback interface. That will be selected as your router ID. And if you haven't configured loopback also, in that case, it will check highest IP on any physical interface. This is how router ID will be elected. Either you have manually configured it. If you have manually configured it, router will elect that as a router ID. If you have not manually configured, in that case, highest IP on any loopback interface. Let's say sometimes we connect 4 to 5 loopbacks on R2 for routing configuration. So out of those 5, which one is the highest? That will be elected as the router ID. If you have not configured a loopback also, in that case, highest IP on any physical interface, that will be elected as router ID. Clear? Okay. So your router ID, it is written in the form. It is again of 32 bits. Okay. And written in the form. Same like IPv4 address. Okay. So when you are manually configuring, so it doesn't have to be IP address available on the router. You can configure anything as per your choice. Like if you are configuring on R1, you can say 1.1.1.1, on R2, 2.2.2.2. So it doesn't really have to be IP address. You can configure anything as of your choice. You can decide what you want to configure and you can configure it, but it should be in this format. This is clear. How you will manually configure it? So when you are configuring, like router, OSPF, and then here you will give the process ID. Okay. Then after here, you can configure router ID. You can use the router ID command and you can give it in the format. Okay. Then after you can start giving the networks. This is how you will manually configure. If you are not manually configuring it, rest of the two things your router will check by itself. You have only one option, that is to give router ID manually. If you don't want to give, router will elect automatically between the loopback or physical. This is clear? Okay, note it down. This is clear? Okay. Now let's talk about how will you configure the OSPF. So for configuring OSPF, you'll see router OSPF, and here you will give the process ID. Then after, you can give router ID if required, not mandatory. It is not mandatory to give, it is up to us, optional. Okay, but if you want to give, you will use the command router ID, and then you can give it in the format. Okay. In the IPv4 format, then you'll say network. Okay, and here you will give the directly connected network ID, same like RIP and AGRP we have done. Okay, directly connected network or route network with the C code in the routing table. Same thing. So you will say here network ID. Then here we use wildcard mask. Now subnet mask, you know, wildcard you don't know right now. Then you say area and area ID. This is your OSPF configuration. Okay. Now what is wildcard? Wildcard mask is equals to 4 times 255 minus your subnet mask. Just reduce your subnet mask from 4 times 255. That will be what? Your wildcard mask. So for an example, you have subnet mask something like 255.255.255.0 /24. So if I want to calculate the wildcard, what I'll do is 0.0.0.255. Correct. So 4 times 255. From that, I'll subtract 255 dot 0, and this will give me wildcard mask 0.00255. So this will be what my wildcard mask. This is your wildcard mask. Okay. This is clear. So let's go and see the basic configuration of your OSPF. Whatever. Okay. Wildcard will be accordingly. That's why in some books, when you will study about your wildcard mask, it will say it is reverse of your subnet mask. So sometimes that create confusion. That okay, wherever 255 you make 0, and wherever 0 you make 255. This is how they say reverse of subnet mask. But when you have 240 and all, then it will create confusion. So that's why the better way to say it is actual formula is this only. 4 times 255 minus subnet mask. And if you want to say reverse, then you are saying that is in the binary, all the ones to zeros and all the zeros to ones. But rather than having confusion, this is fine. Okay. So sorry. Let's take two routers. So I'll use 192.168.12.0 class 24. This side we'll use loopback 10.1.1.2 class 24. 21.1.2 class 24. 31.1.2 class 24. 41.1.2 class 24. Okay. And this will be 192.168.12.1. How many of you think IPv6 is complicated? Do you think IPv6 is complicated? Sorry? You don't know? I think during IPv4, when I started IPv4, I showed you how the IPv6 looks like. Seems like difficult. That is the thing. But it is compared to your V4, it is far easy. No subnet. Definitely. Definitely we'll go through it and you'll see that first thing is what? The best thing is no subnetting. Tension free. Why we are taking so much time in IPv4? Because it makes your IPv6 very easy. Okay, let's go and configure it. Notepad. R1, enable configuration terminal, mistake. Host name R1. No step down. R1 configuration down. Surface back one. IP address. Go back to 20, 3, 30, 4, 40. Okay. Copy. Copy. Done. Let's go and check on R1 about the routes. No route. Okay. So now what we'll consider OSPF here. Okay. So let's consider it. For OSPF, we need to consider these belong to an area. So let's say all of these, they belong to one area. The color is not good. Now visible. Okay. So we'll consider these all belongs to area 0, backbone area. Because although we have to go with a single area concept. Okay. Now what? Let's go and configure it. Router, OSPF, and process ID. Let's say, see, normally we say that, okay, things have to be same. What I'll do here, I'll use different. On R1, I'll use process ID 1. On R2, I'll use 2. So that you can verify that, okay, this doesn't have to be same. Okay. Router ID, I'll not give it. So what will be the router ID on R1? 12.1 will become, because first of all, not manually configured, no loopback interface, automatically physically interface IP. What about R2? Manually, we will not configure. So it will become highest loopback IP. Now, what is the highest IP on the loopbacks? 40. So this will become the router ID. Okay. So directly I'll give network. Directly connected. 12.0, we can see that, okay, with the C code, we have 12.0. Subnet mask is /24. This will be wildcard. Area ID 0. This is your worst case configuration down. Now let's go to R2. Same sort of configuration will give you. To show IP interface, to show IP route. Okay, from here I can see that, okay, 10, 20, 30, 40, and 12.0. router OSPF2. Okay. Then after directly let's say network 10.1.1.0.255 area 0. This will be 20. This will be 30. This will be 40. Network 192.168.12.0. 255 area ID. Then you will see they will become neighbors. And it will become neighbor with the router ID of this. So router ID is 12.1. Same way on R1 when you will check, it will say router ID this. So you see it is saying neighbor 12.1. Same way R1 will say neighbor 4112. With the router ID it will say, see here. If you open here, now check. Neighbor 4112. So they are identified with their router ID, not with their IP addresses. Okay. Now on R1 I can go and check the routes also. To show IP route. Okay. So we have network for route for 10, 20, 30, and 40. You can see cross AD value is 110. Clear? Now let's try to ping. Do ping 10.1.1.2. We have communication 10.1.1.3. Oh, sorry. This will be 21.1.2. We have communication 31.1.2. And we have 41.1. We have the communication. Okay. This is how your OSPF configuration is done. This is clear. Now let's talk about the DR and BDR concept. That what is the DR and BDR concept? Guys, online people, any doubts so far?
No, sir.
R1, R2, R3, R4, R5. 5 routers I'm taking here. And these 5 routers, they are connected with a switch. This is our network setup. This is clear. Now, here I'll configure the IP 10.1.1.1. Here I'll configure the IP address 10.1.1.2. This is R3 10.1.1.3. This is R4 10.1.1.4. This is R5 10.1.1.5. What will be their router IDs? Same IP addresses. The IP addresses will become their router IDs. Okay. Okay. About dynamic routing, we have discussed that, okay, in dynamic routing, what will happen? The routers, they will become neighbors of each other. Correct? They will become each other's neighbors. And if there is any change on any neighbor, if there is any change on any router, it will inform all its neighbors. The neighboring routers, it is going to inform. Okay. Now understand here. If I consider that if I go and configure OSPF here, so for R1, who will become the neighbors? For R1, who will become the neighbors? R2 will become neighbor because see, switch, that means everybody is in the same network. So R2 will become, R3 will become, R4 will become, and R5 will become neighbors. For R2, who will become the neighbors? R1, R3, R4, and R5. For R3, who will become neighbors? Correct. For R4? And for R5? R4. These guys will become neighbors, right? Okay. Now let's consider a scenario. Okay. There is some new information coming on R1. Now R1 is supposed to tell all its neighbors. So R1 is going to say to R1, sorry, R1 is going to inform R2, is going to inform R3, is going to inform R4 also, is going to inform R5 also. This thing is clear? Okay. Now, if you see here, R2 received some new information. Now R2 is supposed to inform all its neighbors. So what R2 is going to do? R2 is going to say, hey, everybody, I have received some new information. So it has received information from where? R1. So to R1, it will not inform, but to all other neighbors, it will send the information. Correct? Because there is a rule called as split horizon. The information from where it came, we don't send it back there. Otherwise, it will create loops. Because I will send it back to him, he will send it back to me. Again, I will send it back to him, he will send it back to me. So to avoid this loop, we have split horizon, that I will not send the information back to the source. Okay. All right. Same way, when R1 shared the information, R3 also received. Now R3 is also supposed to inform all its neighbors. So what R3 is going to do? I will not inform R1, but I will inform R2. I will inform R4 and R5. No. First of all, we are considering the case only when they receive the information from R1. We are not even going there yet. Right now, we are just considering this red information that came in. Same way, R4 also received. Now R4 will also inform all its neighbors. Correct. Send it here. Send it here. Send it here. Same way, R5 also received the information. So R5 will also inform here, here, and here. This is just the information that R1 shared. Now after that, R2 also shared, R3 also shared, R4 also shared, and R5 also shared. Can you imagine the amount of information that will be? Same message, one message, how long it will keep on traveling, and it will keep on multiplying. It will keep on multiplying. So why it is happening? Because everybody is becoming neighbor and sharing information with each other, right? Everybody is becoming neighbor and everybody is sharing information with everybody. This is the problem. Understood the problem? Now let's come to the solution. Solution is your DR and BDR. So out of all these routers, one of the router will be elected as DR. One of the router will be elected as what? DR stands for designated router. You know, like in the villages, everybody is equal, but a person is elected who is going to handle everything in the village. What do you call them? Sarpanch, right? Mayor. So if the mayor or the sarpanch is not there in the village, let's say DR is dead, now what? That's why we have backup, like for president, vice president, right? Same like that for DR, we have backup DR. backup designated route. These are the routers with the highest priority. The router with the highest priority will be DR, and the router with the second highest priority will be VDR. This is clear. But the thing is, by default, everybody is equal in the village also, in the OSPF also. Everybody has the priority one only. This is where your router ID comes in picture again. The router with the highest router ID will become DR. The router with the highest ID will become the DR. So by default, R5 will have the highest ID. R5 will become the DR. And second highest will become what? VDR. That is backup DR. This is clear. Once this election is done, now these neighborships will break. They will not become full neighbors. They will not become neighbor with everyone. They will not share information with everyone. Okay. In that case, what will happen? Understand. Now, let's say this is elected as DR. This is elected as BDR. Okay. So in the router, you will see this as a DR. You will see this as a BDR. And the remaining routers, they will be known as DR other. This is the role of them. Neither the DR nor the BDR. This is DR other. This is also DR other. Clear? Now this is not there. Once DR BDR is elected, they will not become like these neighbors. Okay. This is clear. So now if there is any new information on a DR other, what it is going to do? It is going to inform only DR and BDR on. Only these two routers. It will not inform to these routers. Okay. And as long as your DR is available, your BDR will remain silent. He will not do anything. As long as Mayor is available, everybody else sits silent. Right? Same thing. So as long as DR is available, your BDR will remain silent. It will receive the information, but it will not share it with anyone. Okay. Now, once the DR receives the information, now it is the responsibility of DR to inform everybody in the network. So DR will do what? It will inform everyone. And when DR will inform, everybody is going to receive it. This is clear. So now the thing is how your DR other will come to know that, okay, it has to share the information with DR and BDR only. How it can send the information only to these two people. Okay. So in OSPF, we have something called as multicast groups. Okay. Kind of, you can say these are 5 people and they are having 2 WhatsApp groups. Okay. One WhatsApp group name is what? 224.0.0.6. This is one WhatsApp group. Who is the member of this group? Only your DR and BDR. These are 2 people who are member of this group. There is another group, 224.0.0.5. Who is the member of this group? Your DR, BDR, and DR others. Okay. Now, this DR other will share the information here on this address. Okay. So when your DR other will share the information here on this address, so it will use 224.0.0.6 address as a destination. And when your destination is 224.0.0.6, okay, see here. 224.0.0.6. Traffic will go only for DR and BDR. And when it is going for 224.0.0.5, everybody will receive it. Same thing is here. 224.0.0.6. So information will go only for DR and BDR. And when the DR will share the information, DR will use the address 224.0.0.5. This is the address your DR is going to use. So what will happen? This information will go to everybody. This is clear. Okay. Now DR BDR, this is by default implemented in the OSPF. We do not implement. It is already there. Okay. So understood how your DR BDR concept works. What is DR? What is BDR? Okay. Online people. Is it clear?
Yes, sir.
All right. So now let's go and configure. So according to our calculations, R5 should become a DR, R4 should become BDR, right? So let's see this thing practically. I'll go to Notepad and directly I'll configure here. So 10.1.1.1. And here itself, I will configure OSPF because for DR BDR, there is no special configuration required. You just configure OSPF, DR BDR election will be done automatically. Okay. So directly I'll say router OSPF1 network 10.1.1.0 area. This is my configuration for R1 done. Copy it. R2. Only IP address information will change, nothing else will change. R3. R4. R4 done, right? Now one by one, let's copy and paste. R5 configuration done. R4. R3. R1. Yeah. Now let's just go on R1 and let's check. See, when you configure OSPF, OSPF creates three tables. Okay. OSPF will create three tables. OSPF creates three tables. Table number one is known as neighbor table. Okay. Neighbor table is the list of neighboring locations. Okay. How do you check it? You give the command show IP OSPF neighbor. Table number 2. OSPF database. List of link state advertisement. Okay. So link state advertisement is the routing update of your OSPF, the routing information. How do you check it? You say show IP OSPF database. Okay. Then after number 3, routing. So first of all, your neighbor table is created. From the neighbors, link state advertisements are received and stored in the database. On the database, the algorithm, Dijkstra's algorithm, SPF algorithm will be run. And finally, best routes will be calculated. Those best routes will be stored where? Routing table. Okay. This is how your OSPF works. List of best routes. How do you check the routing table? So normally you say show IP route. So this will show you all the routes. If you want to check for RIP, you can say RIP. If you want to check static, static. If you want to check AHRP, AHRP. If you want to check OSPF, OSPF. Dedicated routes for OSPF, you can see. Okay. So right now I want to check about the neighbors, because in the neighbor table, I will have information about my neighbors and who became the DR, who became the BDR. All that information will be there. Okay. So let's go and check. If I'm going on R1, and if I try to check here. So first of all, if you see, it became neighbor with only 2 people. DR and BDR. Okay. So I got this log that, okay, full neighborship has been established with DR and BDR only. It is neighbor with others also, but with others, it is not exchanging the database. Okay. They are just hi, hello guys. Okay. They will just say hi, hello, and done. No information sharing. Okay. So if you say do show IP OSPF neighbor, check here. 10115. Neighborship is full, is DR. 10114. Neighborship is full, BDR, but others only two-way. Two-way means I will send hello, you send me hello, done. This is two-way. And what is their role? DR other. Now, like I said, if I will, if this guy will have any new information, he will inform whom? Only DR and BDR. DR and BDR only. So let's go and put some new information here and let's see whether he is sharing with everyone or what. So I'll add a loopback here. Interface loopback 1, IP address 1.1.1.1, 255.255.255.0. Loopback edit. Now I will advertise it into the OSPF. Then only OSPF will inform everybody. So I'll see router OSPF 1 network 1.1.1.0 0.0.0.255 area 0. Okay. Before advertising it, I'll start the capture. And I'll say I just want to capture only OSPF protocol. Okay. Now see. Hit enter. And you will see one message is generated. If I open this message, is what type of message? OSPF. If I click on this message, this is a link state update message. So we'll talk about the message type also. Okay. But if you see what is the destination IP address? 224.0.0.6. DR and BDR only. Okay. Now see here. These guys, they are not member of the group. They will drop the message. And these guys, they are member of the group. They will accept it. Now, as long as your DR is available, your BDR will not do anything. So you can see your DR has generated a new message. Okay. This is a new message. And if you see the information in these messages, it is similar information. If I see inbound packet details, so here in this message, there is an information about a new network. See, there is information about new network that, okay, this is the new network, metric is 1, and this is the data of the link, that means broadcast. Okay, broadcast, sorry, not broadcast, /32, because single IP address it is advertising. Okay, so you can see it is giving this information, and same information you will find in this message which your DR will send to everyone. If I see here in the outbound PDU details, if I scroll down, see here, your DR is also giving the same information, but received from router 1. And now if you see what is the destination IP address here, 005, same message, OSPF link state update only. Now everybody is member of the group, so everybody will accept this message, and R1 who actually generated the message will acknowledge it that okay, everybody has received it. So this is, if you see what it is an acknowledgement message. Okay, and this way the information will be shared, so they will not keep on sharing the information with everyone, and we will not have huge amount of traffic in our network. Yeah. How the router going to know that? See, router is not going to know about who will be DR, who will be BDR. Okay, it will just use the address 224006. So if the destination is 224006, then it will automatically come to know that okay, this message will go to DR and BDR only. Is it clear, Chami?
Sir, can you please do same thing in the real-time mode?
Just 1 minute, just 1 minute. Your voice is low. Yes, please tell me now.
Can you please do the same thing in the real-time mode in the console CLI?
Like which thing in the CLI?
This message thing, transferring the message.
Messages we cannot capture, right? In the CLI. In the CLI, we cannot capture the messages. If you want to see, then you have to debug. Okay, like if I want to debug here, I can say something like, let me say no. Okay, so whether a network is removed or added, everything will be done by the OSPF itself. So you can go here and you can say debug IP OSPF events. Okay, now route configure terminal, and again I will give that comment. Oh, sorry, router OSPF 1. With the debug, this is the thing, you'll get a lot of messages. Okay, so let's see if you see. And on R5, let me start debug. Do debug IP. See. Now here you will have to find out the messages, because so many messages, all the messages that will be traveling, they will come here. Let me go to R1 and here. Let me see. Okay. This will not stop. But if you see here, source and destination and all these messages, it is telling you that you have received on 224.0.0.6. Okay. So this is
Okay.
continuous. In debug, you will not be able to see in the CLI.
Okay.
Now let me see. So you will get this kind of messages that there was a packet, source was 10.1.1.1, destination was 224.0.0.6. Okay. Then here it is saying source was 10.1.1.5 and destination was 224.0.0.5. This way you will be able to see. Okay. And see here sending, broadcast or multicast traffic.
Okay, so by applying the OSPF, router automatically get the DR and BDR as
Yes.
10.1.1.4 and 10.1.1.5, right?
Correct, correct. Okay. Yeah. Got it?
Yeah.
Okay. Any doubt? DR, BDR clear? Okay. Now, next thing, let's talk about okay, so for DR election, first of all, highest priority will be checked. So priority is between 0 to 255. By default, priority is 1. Okay. So the router with the highest priority will be elected as DR. And if priority is a tie, highest router ID will become DR. Same way, who will become VDR? Second highest priority, second highest router ID. Clear? Now let's talk about your OSPF, neighborship states, and packet types. So OSPF uses 5 packet types: hello, database description, link state request, link state update, and link state acknowledgement. These are the 5 messages your OSPF uses. So in short, to these messages, we call them hello. This one we call it as DBD, database description. This one we call it as a link state request. This one we call it as a link state update. And this one we call it as a link state acknowledgement to LS act. Okay. Now, let's consider you have 2 routers. This is router number 1. This is router number 2. And they are connected. Okay. You can consider their IP addresses. Let's say this guy has 10.1.1.1 and this guy has 10.1.1.2. Okay. This is your R1. This one is R2. Okay. Now, when you have not configured OSPF, then there will be no neighbor definitely. So your neighborship state will be what? Your neighborship will be in the downstate. Now one is neighbor. Now what? As soon as you configure OSPF, let's say you configure on R1, R1 will send a message here. And this message will be known as what? This message will be known as hello message. Okay. And as soon as R1 is sending the hello message, it will change the state to init. That means initialized. Okay. The state changes to init. So hello messages, these are used to discover the neighbor and maintain the neighborship. That my neighbor is available or not available. Okay. Then when you go and configure it on R2, R2 will also share hello message to discover its neighbors. So R2 will share hello. So now on R1 side, you have sent, you have received. That means two-way communication has been established. Once two-way communication has been established here, the state will change to two-way. The state is two-way. That means now I have two-way communication. And in this state itself, they will start electing DR and BDR because in the hello message, router ID information will be there. So all the routers, they will exchange the hello messages. They will come to know that, okay, how many routers are there in the area. Then they will start electing that, okay, who has the highest router ID? He will become DR. Who has the second highest router ID? He will become BDR. Okay. Now, those who became DR and BDR and DR other, they will take up their roles. Once it is done, now it is time for exchanging the database. Okay. But again, R1 and R2, they will think that, okay, who will share? R1 will share or R2 will share? Don't know who will share. Okay. So they will say, okay, for this thing also, let's do election. For this thing also, let's have the election that, okay, who is going to share the information first? Who is going to share the database first? So what they will do that, okay, fine, what we are going to do is that I will share a database packet. Okay. They will say that, okay, I'm going to share a database packet with you, but I'll not share any information with it because we don't know who has to share the database first. So they will share what? They will share empty databases. The second packet. They will share the database description packet, which is used to share the databases, but they will not put up any information in this. That means empty packets they are going to send. This guy will also send what? Empty. So that means now they are preparing each other for sharing the database. So their state will change. And to which state it will change? It will change to X start. That exchange has started, but they are not really exchanging. They are not really exchanging the database. Okay. So here again, a election will happen, master and slave. Okay. Who will become the master? Master router will share the database first. Slave will just respond to the master. Okay. So again, router with the highest router ID will definitely become master. So let's say R2 became the master. Now R2 will do what? R2 will exchange the database information first. Okay. R2 will share the information of the database. And same way in response, R1 will also share. Okay, now they are actually exchanging the database. So the state will change to exchange because they are actually exchanging the database. Now, once they have exchanged the database, let's say R1 came to know that, okay, there is a particular information in the database for which I need more information. For which I need more information. There is a particular network or route for which I need more information. So R1 is going to request R2 for more information. And for requesting, it will use LSR, link state request. So let's say this message. So R1 is going to say that, okay, I need more information about one particular route. So for this reason, it will use a message which is known as LSR. Okay. Router 2 will receive the request. So router 2 will send the update. Okay. How router 2 will respond to it? Using an update. So it will send what? LSU. Link state update. Same way, if R2 needs information, it will send LSR and R1 will send LSU. So this time what they are doing, they are completing the missing information. They are completing the missing information. Okay. And they are preparing the routes. So now what? This state will be known as loading. This state will be known as loading when they are completing the missing information. Then once they have completed the missing information, that means both are having the same database. Both are having the full information about each other. So there comes the final state, which is full. There comes your final state full. And since your OSPF is a reliable protocol, for a database description for link state request and link state update, there will be a acknowledgement. They will acknowledge that, okay, I have received your information. And this is how these states changes. This is how these messages are going. Now this is clear. What are the neighborship states? What are the messages? Yes or no? Clear? Online people? Clear? Okay. And this is the reason when you check OSPF, okay? So they will say, now in this one, there's too many lots. Let me show you in this one. So what they are going to say, that your state changed from loading to full. That means they have completed the database exchange with these two people. They are not exchanging complete database with everybody. They are only exchanging complete database with DR and BDR. For others, they will only exchange your hello messages. That means they will remain in the two-way state only. Okay. They are going to remain in this state only here, where they are just exchanging hello messages. They are not even going for master slave or database exchange or any other thing. Is that clear? Okay. Now about OSPF, one small concept is also there. And after that, your OSPF completes, which is this one. LSDB, LSA, and ACL. So ACL is a different concept. Right now, we have to go with the LSDB. LSDB, link state database or OSPF database. How do you check it? You give the command show IP OSPF database. Remember? Show IP OSPF database. Correct? The second table you just noted, right? So in the database, I said there will be information about the link state advertisements. So there are total 7 types of LSEs. But right now we are having single area OSPF only. So according to single area OSPF, we will have information about 2 types of. Okay, remaining will be used in the multi-area OSPF. Okay, so now what? The 2 types of LSA that we are having, type 1 LSA, which is router LSA. This is the type 1 LSA, which is known as router LSA. So what is the router LSA? First thing you need to know about it is this particular LSA generated by all the routers in an area. Every router in your area will generate type 1 LSA. Okay. And with the help of type 1 LSA only, everybody will come to know how many routers are there in the area. Because if everybody is generating, that means they are giving information about self. Okay. So if everybody is generating, everybody will come to know how many routers are there in the area. Okay. And the scope of this LSA, that means how far this will travel. So this will remain within an area only. This will never go out of the area. And this is when I said in the area, all the routers, they will have information about themselves. They will not have information about any other area. They don't know that, okay, how many routers are available in the second area. They will know about the cell phone. This is clear. So when we will go and check the OSPF database, so according to our current topology, DR-BDR topology, in the type 1 LSA, we will have information about 5 routers, R1, R2, R3, R4, and R5, because everybody is generating it. Okay. Then comes the type 2 LSA. Okay. Next comes your type 2 LSA. So type 2 LSA, this is not generated by everyone. Okay. This is generated by DR only, not even BDR. Only DR will generate it. That means everybody will come to know who is the DR. By looking at the second type LSA, everybody will come to know who is the designated router. This is how OSPF is exchanging the information. Okay. So again, what will be the scope? Scope will be, since we are talking about single area only, so this will remain within an area only. This type of LSA will also not go out of the area. Is it clear? Now let's go and check. Okay. In our topology, let's go and check. So we know that, okay, which router is the DR? This is the DR. And the other one, this is the DDR. And the remaining are DR others. So when I will check type 1 LSA, when I'll check the OSPF database in the type 1, in the router LSA, the name is what? Router LSA. I will have information about R1. I will have information about R2. I will have about R3, R4, and R5 because everybody is generating. But when I'll see the type 2 LSA information, which is also known as network LSA, here I will have information about only one router, which is R5, which is the DR only. Everybody generates type 1 LSA, only DR generates type 2 LSA, not even your BDR. This is clear? Let's go and check it. Let's go on R1 and we'll check. Enable to IP OSPF database. Wait a minute. How come R3 is becoming DR here? To IP OSPF enable. Range. Just a minute. Here IP to IP OSPF database. Sometimes packet tracer will create issue. See? It is considering itself as a DR. Let's fast forward so that they will exchange all the information and everything. Okay, it's this is different. Now it's fine. Okay. Packet tracer sometimes will create issue. So you can see that in the router link state, I have information about all the 5 routers. R1, R2, R3, R4, and R5. Because everybody generates it. And in the network link state, I will have information about DR only. This is how everybody will come to know that, okay, who is the DR. Same way, other type of LSA also different, like type 3 LSA will have information about area border router. That, okay, if I want to communicate with the second area, where I have to send the packets. This is how OSPF will create the database. Then based on this database information, OSPF will create the routes. Clear? Any doubt? All right. So right now, only 2 type of LSA you will study. In your CCNP, you will study all the 7, 8 types. Okay. Because they will be working with multi-area. And in single area here, you can see even not even available right now. Only 2 types of LSAs you are able to see here. If you have multi-area configuration, more than 2 will be there. Clear? No, not right now. No. Okay, because if I go into ABR, then I'll have to cover ABR also. I'll have to cover virtual link concept also. That will keep on adding. That is good. This is clear. So this was your OSPF according to CCNA level. See, CCNA will be very small things only. Okay. Furthermore, configurations, deeper protocols, NP will be there. Okay. I'll close it. Any doubts? No? Then with this, your OSPF is complete. Okay. Now, next thing we have to start with ACL, which will start tomorrow. Okay. All right, then. I'll see you guys tomorrow. Online people, any doubt?
No, sir.
All right. Okay, then see you guys tomorrow. Have a good day.